Today in Aspire, we will learn how to create parametric designs. As you can see on the screen here, these are some designs that are usually attached to walls. We can also call them wall panels. There are countless types of parametric designs, but the one we are going to discuss today is especially for walls. Let me share some more designs with you, like this one you can see here, and this one as well. These are very top famous designs. So our topic today is parametric wall design, and that's what we'll be working on. Let's get started. First of all, you need to have a clear understanding of the basic concept. This design is created in 3D. The look you see here, you first need to create this look in 3D, and after that, you will slice it. With the slice tool, you'll get its cross sections. From there, you need to use the cross sections for cutting, and then you will extrude each cross section to create a 3D file from it. By importing them into a new file, you'll be able to see this preview. Now, if you or your customer needs a preview, then go to the preview site. Otherwise, it's not necessary. It's easy, just focus on 3D design. Let's start. I created a new 48 by 48 inch file in Aspire, initially 0.75 inches thick. We'll change it to 2 inches for 3D work, making the bottom thickness 2 inches. Let's get started. You can set its XY datum position anywhere you like, according to your preference. Click OK. After clicking OK, since the design we're about to make is a wave design, which you can also see here on the screen, it's oriented lengthwise. In other words, its width is greater and its height is less. So we're making it in a square form. The design will be the same, and in this, you need to keep a few things in mind here. There are 2 or 3 elements involved. If you look at it, the first thing is that a ridge is being placed on the inside, and then the entire outer surface is on one extrusion. And if you look here, it has 59 bytes of lead, and then first, that valuable part was placed there. This is its curved back. First, let me maintain its values. Here, this bottom strip, you can make it 2 inches, 3 inches, it's up to you. You can design it however you want, according to your needs. Next, let's move to this design here. The position you see here will create this shape using the 3D tool. But before making the shape, we need to create its cross-section. What is the cross-section? From here, the position of the bar, whether it's up or down, will be represented in the cross-section, and we'll revolve this cross-section around it to create the design. Let's get started. First, just to give you an idea, I'm drawing a circle. Right at its midpoint, I've placed a circle. Here, I'll set the diameter of the circle to 12 inches. Take a look. After that, we'll go to offset, and I'm offsetting it at 6 inches each time, so you can see this way I've drawn the basic design. Now, try to understand this. This circle here has its midpoint, meaning its center point, and from the center point, it's 6 inches, then another 6 inches, then another 6 inches, and another 6 inches. So in this way, the total size becomes 24 inches. I'll close the offset now. After this, look, the most important thing to understand here is I'm just placing it, click on the ruler, bring it here, and drop it at its midpoint or center. Now we have a center guideline. From here, we need to pull the guideline up and down so that when we create the zigzag here, it becomes easier for us. So first we need to bring the line here so we can draw the belt design here at their midpoint. Keep the essential guideline here and carefully select the appropriate tool. Now on my expansive canvas, precisely select the versatile pen tool, the accurate selection tool, or the incredibly useful ultra tool, whichever specific one you truly need for your current work. So how exactly do you accomplish this? Just simply right-click, and whichever particular tool you genuinely need for your ongoing work, carefully select that precise one. So here, the guideline we placed earlier, at this spot, I'm going to offset it. What do I need to do? I'm calling it a relative guide. How many should be placed here? From here, 1, 2, 3, 4, 5, 6, 7. So like this, you can divide it into 7 or 8 sections, or assign it a quantity of 7 or 8. Since we're doing it relatively, from one to the next and then to the third, from here to here, the distance between the lines is 3 inches. Then from here to here again 3, and then again 3 from here to here. So this is how we'll do it. Now, if you look here, the value is going towards the negative side, right? It's decreasing. So here, set it to -3 and create a new guideline. So you saw that the line started from here, and at intervals of 3 inches, a line was drawn and the guideline appeared here. In the same way, look, this portion of the guideline on one side is now complete. Since the other side is the same, you don't need to work on the whole thing. Anyway, the cross section I'm about to make will be for one side, and the rest will revolve around it. In the same way, I selected this guideline, right-clicked on it, and after right-clicking, look, it's showing its position here at 24 inches. And here, if you see, we have two options. One is its absolute position, meaning its 0 value. Second, on the relative position, look here. I call this the relative position. First, do create new on the first two. It created one on those two. Then, in the same way, I set this one to minus here and clicked create new. So it created one at the minus position. So you see, this is how we set its position. Now it depends on you. I'm giving you an exercise. I'm going to move these 1/2 inch down, like this. I want to set its position 1/2 inch down. I'm just giving this for practice. It's not necessary. So look here. This is the new position. Right now, I set it at 6.20. If I set it to 25.5 and apply it, you'll see it moves down, okay? But we don't need this, so I'll move it back to 6.20. And now it's back at 6.20. I want to move its position 1/2 inch down. I'm just doing this for practice. It's not necessary. So look, this is the new position. Right now I set it at 26. If I set it to 25.5 and apply, you'll see it moves down, okay? But we don't need this, so I'll move it back to 26. And now it's back at 26. Close it. Now look, we have this guide, this guideline. Inside this, we need to create a cross section. So look, here I'm going to draw a curve, which we also usually call a polyline. I'm about to draw a curve. Now pay attention to this part. Here, I've selected draw curve, and I started from here, gave this curve, then this curve. Now keep following along. I need to use these points. Now, in the same position, I did this, and then from here, I made it straight. Okay, we extended its direction outward a bit more, because when we rotate it, it needs to reach the corner here. So the length of this line should be longer. Press end here. Note that all the nodes here are straight, so make this node straight as well, so that its curve matches accordingly. Now you can pull this design out as much as you want from here. I'm going to exaggerate it a bit more. Here it is. In the same way, let's come to this side as well. Look at all these curves. See, the anchors are coming straight from below. So grab this anchor and straighten it above. Grab this anchor too and straighten it above. This way, the line becomes tangent and straight with it. So now we have a curve for the cross section. Now, these guidelines that are set up, I don't need them anymore. So I'll select them from here and delete them. Just delete them. See, they're getting deleted like this. If you want to turn them off, you can turn them off from here. But if you turn them off, they come back on again. I don't need them, so I'm just deleting them one by one. Another way is to drag them out and throw them away, and they'll get deleted that way too. So I've deleted them up to this point. And now the next thing we need to do is you need to select this curve, then go into modeling. After entering modeling, you'll find a tool here called create a shape by the spinning or turning a vector. This is the revolve command. So when I go to this, make sure to turn on 3D mode so you can understand better. In 2D, you've selected the object. See, this object is selected. And from here, you need to spin it around the left. End point around left end point. That means this is the right point and this is the left. So it's going to spin it from the left end point. Now it has drawn the design exactly over its center. Now, if you look at its curvature, it's the same from all sides. You can see here that there's no issue in the middle, and this thing has been created. Now, the problem you might be facing here is that its thickness has decreased. Change the properties of the selected component. When you come here, you can give up to 1 inch of thickness to its base. Look, we've given it 1 inch of thickness at the bottom. In the same way, you can bring it back again, and here, after that, you have scale Z height of model. You can also control its height a little from here. See, if you are seeing too many steps, you can adjust it from here as well. You can also slightly increase or decrease the steps, but the base height will automatically change accordingly, so that's not really an issue. I'll cancel this. I kept all the values as they were. After that, I bring it back here again. Its height is already set to 1. Go ahead and bake it here. After baking, I gave it height again. So see, it had 1 inch of height before, and now it has gained another inch of height. You can bake it, and as you did, you can give it another inch of height. Look, this is the design. I clarified and heightened it for better understanding during design. Go back to drawing mode, switch to 2D. This sketch that, we don't need these lines anymore, we don't need them now. Our main design, as you can see, has already been created here. Now, what we need is to decide the gap for slicing this design. Look at the gap. Usually, the thickness we have is a 1/4 inch sheet. So if we have a 1/4 inch sheet and then a 1/4 inch gap, then another 1/4 inch sheet and then another 1/4 inch gap, and so on. So if you want to create a design like this, what does it mean? It means that when you slice it from here, there should be a 1.5 inch gap in between. You need to add a guideline. Right-click on the guideline, set it to Relative to Guideline, and then give it a value of 1.5. After setting the value, you need to specify the number of guides. Now, how many guides do you need? Look, it's very simple. If you turn on the calculator, I'm bringing the calculator up on the screen. When you turn it on, you have half of it here, which is 24 inches. So divide that by 1.5, and you'll get a total of 16 guides. So I set it to 16 here and click Create. As soon as I click Create, you can see that the guidelines have been added. Now, if you start from here, the half, meaning a 1/4 inch, will come here, then a 1/4 inch gap, and then another 1/4 inch gap. A 1/4 inch sheet will come, then a 1/4 inch gap, then another 1/4 inch, and in this way, your parametric design or wall design will be created. For your convenience, you should add another guideline here so that when we select it, we can easily find the guide. After doing this much work, make sure to keep saving the file as you go, because saving the file is very important. Now what we need to do is we have a tool available called Measure Distance, Area, Length. You need to come here, and looking at these different options, you'll find the last option is Model Cross Section. So set the Model Cross Section, and you just need to connect this point to that point. Now make sure that your line starts from the correct place, and then you select the second point. Take it from here and make sure to keep the direction the same. You have to create all of them from the same side. So I selected this second point. The slight arrow you see here is exactly because of this. Take it from here and keep the direction the same. You have to make all of them from the same side. So I marked this second point. The slight arrow you see here, don't worry about it at all. Look, I took this point, that was the third one, I skipped it, and now I'm bringing it to the fourth one. Here, I marked the point. Now we are moving on to the fifth one in the sequence, and simultaneously you can clearly observe that its intricate cross-sections are progressively being formed with remarkable precision. Just look closely. I have now carefully selected it from this specific point once again. The more extensive your selection becomes, the more numerous and detailed its corresponding cross-sections are automatically and seamlessly generated further along the path, creating a continuous and evolving structure right before your eyes. This dynamic process highlights the efficiency and responsiveness of the system as it meticulously constructs each new segment based on your input, ensuring a comprehensive and visually rich representation of the object's internal structure. That we set, or the distance we determined, that we have to place them at 1.5 inches apart, all those guidelines that we set, or the distance we determined that we have to place them at 1.5 inches apart, after making all those cross sections according to the guidelines, now I'll move these cross sections back by giving them some distance so that we can easily do further work on them. So look, these 3 circles, or these 4 circles, and the cross section we made, right click on them and move to new. Layer, I created a layer named section, gave it a color, and now see, it is moved to this layer. Turn this layer off so that we don't run into any problems. Now, for all the designs you've made, start separating them one by one. How will that work? Now, this layer, I created a layer named section, gave it a color, and now, see, it is moved to this layer. Turn this layer off so that we don't run into any problems. Now, for all the designs you've made, start separating them one by one. How will that work? Now, I'm going to turn off these guidelines from here. I'm turning them off. The guidelines are off now, and look, I've selected this object. Turn on the Move command. Keep selecting the objects and placing them outside. Use the Alt key to help you keep the design straight. Now, I've selected this object and placed it close by. In the same way, select this one and place it nearby as well. It's good to do this step by step so it's easier to arrange your design. Select the object. Now, from here, use this join command that we have. Use it so that the last lines get joined together. See, because we need this vector in a closed form, I selected this object and closed it as well. While closing it, use the Alt key and bring it close, placing it right there. Then I selected the next object, closed or joined it in the same way, and placed it next to the previous one so that the gap in between, although we can adjust it later if needed. So this is one thing. See, now all the cross sections that were created have been arranged here in order. In the same way, if I select all of them together, like this and this, I've selected the objects. You can also maintain them from here, but I want to guide you on something here. You only need to select the cross sections. Press Ctrl+C and open a new file. I've opened a new file in Aspire. Remember, when setting the sheet size, make it slightly larger. I'm increasing it from both sides. I'm setting the thickness to 0.7. I'll explain why later. For now, I've placed this file here. Press Ctrl+V to paste the copied content. I brought it here and pasted it. Okay, now this data has come here. Since the design we made won't fit on a half sheet, we'll need a bigger sheet for this. So I'll double the sheet size from here. That is, I'll increase its height, basically making it double. The full 8x4 sheet, I'll set it according to that. I brought it here and pasted it. Okay, now this data has come here. Since the design we made won't fit on a half sheet, we'll need a bigger sheet for this. So I'll double the sheet size from here. That is, I'll increase its height, basically making it double. The full 8x4 sheet, I'm setting it according to that. Now, since you don't have an 8x4 sheet, you have 49, meaning there's no sheet bigger than 48 inches, so I had you set it to 49 inches. This ensures your design fits completely within it. Even at 48 by 96 with a 0.75 thickness, it's fine. We'll adjust another way. Nesting is one way. For nesting, I set the tool diameter to 0.125, clearance to 0.0625, and then the border gap. This border gap is from the outside edge. Apply and preview. There might be an issue as some are placed one above the other and others separately. The vertically stacked ones, nesting, tool diameter 0.125, clearance 0.0625, border gap from outside edge. Applying/previewing may show an issue. Some stacked vertically, others separate. Vertically stacked items have a problem. What I was trying to show you is right here. Now, as I previewed the nesting in front of you, since the design we just made, its length, what I was trying to show you is right here. Now, as we previewed the nesting in front of you, since the design we just made has a length of 48 inches and we're leaving a border gap of 0.25 on the sides, it will adjust it by tilting it a bit because its length is already equal to the sheet. Now, I'm canceling it here, and also look at this. What we have, use the move command for this. I'm not placing it exactly on top of it. I'm setting it like this. See, I'm just maintaining its alignment. This, and this. So in this way, we've created an arrangement. But keep this in mind. Whatever you've made, you need an exact copy of it. The reason is that we worked on half of it. So look, I'm taking a copy of it from here, and I bring it over to this side as well and place it here. Now keep this in mind. Whatever we're about to do, if you do it here as well, all these cross-section designs we've made will be mirrored. And I bring it over to this side as well and place it here. Now keep this in mind. Whatever we're about to do, if you do it here as well, all these cross-section designs we've made will be mirrored. How will they be mirrored? On this side. And then we'll have to select each one separately and mirror them individually. So we're not getting into that right now. Just simply keep this point in mind. You need to keep in mind how we have to adjust them later on. Meaning this design will go here, that one will go there, and so on. All the designs will become mirrored and opposite. Now, if you still want to do this, I'll guide you. Look, this is the middle design. I select these two designs, and in the mirror option, turn off the copy and flip them horizontally here. See, when you do this, then you'll have to pick each design. You'll also have to meticulously separate each and every one individually, but we will definitely do that at a later, more opportune time. You see, as soon as all these intricate designs begin to move forward from this current position here, the respective positions consistently keep changing into a perfect mirror form. So, after we've diligently done this much extensive work, first and foremost, you must concentrate on precisely aligning them. How exactly do you go about aligning them, you might ask? I need to adjust all of them to the bottom. Now all of their bottoms are aligned. You can either align them to the bottom or center them. Look, this is the center, and here I've also centered their positions relative to each other. After centering them, I'm rotating them to 90 degrees. Now they're rotated. The next step is to save this as you go. The next thing we're going to do is, since we now have this total segment that we've just created, we'll save it. Yes, new to vector, new to 3D, new to I've made its vector. Now we'll bring it into nesting. Look, the first thing I said was to select it, then move to its size. Right now, its width is showing as 48 inches, so I'll reduce its width by half an inch. In fact, I'll reduce it a little more than half an inch so that on the sides, I have some cutting margin left over. So 48 inches, actually, the sheet size I previously told you to use, the larger one, I've changed my mind about that. The reason is you might run into some issues while working on it. So it's better if you make the pieces a little smaller. Actually, it wouldn't have been a problem if you had used the larger sheet size. For the design or in the software, you needed to use a bigger sheet, but when installing it, you had to you would have faced difficulty, but now I'm changing it. I'll set the size to 47 so that I don't run into any kind of problem. The height will also automatically adjust accordingly. When I apply it, the size will be slightly reduced. Close it, and after closing, go to nesting. Now, before doing the nesting, I always recommend saving the file once, because these large, but after you've performed any major activity, make sure to save the file once. Now I'm moving to nesting. The procedure for nesting is the same. I've set the tool's diameter, given clearance from the other side of the tool, and set the border gap to 0.25. After setting the border gap, here I set the rotation for part to find best fit to 1 degree, so it finds the best fit. I've enabled mirror part and all these options, and here I click on preview. When I click preview, it'll take a little time and then generate the preview. But when you're working on nesting, there's one thing you should definitely keep in mind. All the components need to be selected separately. Look at this. When you come to nesting, there's one thing you absolutely need to keep in mind. All the components should be selected separately. See, it has selected all the components individually, and each one has its own boundary. This step is very important. If you notice that two components are joined together and forming a single overall boundary, then you should not proceed with nesting at all. So you should always keep allow parts inside other parts turned off in such cases. Right now, it won't have any effect in this preview, but you should uncheck it here. Usually, we use this option when we want to place a new part inside the hollow area of a very large part, so that's when it's useful. But at this moment, we don't need it here, so we'll have to wait for this processing to complete. As soon as the processing is finished, then we'll see how many sheets it's using, how many sheets the design we just made is taking up. So then we'll see how many sheets it's using, how many sheets the designs we just made will be cut on. It can't be done on just one sheet. That's just not possible because the design is big. So at minimum, it will use 2 or more sheets for this design. But all these decisions will be made after this preview. So please wait for that. Viewers, as soon as the nesting preview process was completed, you can see here that it used a total of 2 sheets, sheet 1 and sheet 2. So in this way, whichever sheet you click on will become active and you can proceed with further processing on it. In fact, it has left a little bit of material unused here. Now, since we made the size a bit smaller, you can see here the position of that size adjustment. Look at this. So as soon as we saw this process in the preview and it matched our requirements, you can go ahead and click OK. Then save the file. After saving the file, go to its toolpath, and here, bring it to the profile toolpath. We had set it to 0.125, meaning a 1/8 inch end mill is installed here. Its depth is set to 0.75, which is fine, and I am doing outside cutting here, meaning the cutting will be on the outside of its edge. It will be done. Click Calculate. I selected the area and set it as Profile 1. Click Calculate, and this is how it gets calculated. Now preview it, and in the preview, it has shown all the pieces like this.